Greetings to one and all present here. Me, Gautham Gopan, along with my co-author Bhavani Sai KB, would like to present our paper on the topic Generation of Realistic Virtual Worlds Using Advanced AI and its Real-World Implications. So this will be the basic structure that we'll be following throughout the PowerPoint. The objective, the methodology, implementations and simulations, the real-world implications, references, and finally we'll be concluding with the SWOT analysis. Now, coming on to the objective or what basically is virtual worlds. The virtual worlds are those digital environments that we create that are completely computerized or computer generated worlds that have no relation or can be either made to replicate an entirely existing real world location. Now, virtual worlds is an extremely budding innovation and a budding technological advancement that has recently come up in the recent times. So there are a lot of questions being both judicial as well as virtual related to the implementations of virtual worlds. So the main objective of this paper is to present an innovative futuristic methodology for generation of virtual worlds that not only make the real world shape or makes it the similarities of the realisticness of the virtual world compared to the original world. We'll also try to create a solution that will be able to generate virtual worlds at a large amount of pace, which will eventually help us to grab the entire attention of the society around the world. Now, the biggest, even though this is an initially budding technology, all the hardware and the software requirements for this project are having a huge industrial growth. Just for example, AI, the virtual reality, augmented reality, photogrammetry, advanced satellite imagery, terrain imagery, all these fields, maybe indirectly or directly related to virtual worlds, are having a huge boom in the market. So basically, compromising all these various facilities, we'll be able to create a system that will be able to digitalize our world much more in a better angle. Maybe it will help us solve a lot of human real life problems in the future. Now, with that thought in mind, let's jump into the methodologies used. Now, the role of AI. So, basically, for betterment of understanding, we have divided the entire methodologies used into different stages. So, this is the first stage. Now, the role of AI in pivotal role is in reconstructing a digital twin of our world. Now, when it comes to creating virtual worlds, like I mentioned previously, there are two methods. Either you can create a virtual world that is similar to a real existent city, or you can create a virtual world that's completely out of the imagination of a creator. Now, when we are trying to replicate real world cities, the biggest problem is that only a very handful cities like New York, the downtown London, or only these very limited amount of cities are available in a three-dimensional format. 99.8 percentage of the world that we know is not being digitized or is not available in a three-dimensional format. Now that is where the reconstructing abilities of an AI comes into place. By using advanced geospatial abilities and terrain imagery and satellite imagery, we will be able to replicate and identify unique points that help the AI engine to replicate the system. If the same work was being done by a normal graphical creator, it would take him millions of years just to get one city done. But by using this technology, we'll be able to source out various images from the clouds platforms that are already having an enormous amount of data with them and collaborate them to create a much more realistic approach to the virtual worlds. And the image that you can see on the right side over here is basically an image that is taken from an virtual world which was created maybe 4 to 5 years ago. But using the blender technology that we are implementing in this project, this is what we are able to arrive upon. You can see that there is much more detailing in this picture. Now, coming to the again to the next in detailing part, whenever we're seeing a movies that has a lot of computer generated graphics involved in them, we always comment on those movies by saying that, oh, this stunt doesn't look real. This there is a lot of glitches in this computer generated graphics. So in the same way, the authenticity of a virtually created world is judged by comparing it to the real world entities. So it is really important to give immense attention to detail. So those details basically include the natural colors that are there in the environment, the grafting that is done to the buildings, the various amount of textures that are present in the virtually created world. So all these details, even though we are able to replicate an entire city, even if there is one single spot of that city that looks unreal to the user, it damages the entire experience of the user. So attention to detail is a huge thing that AI helps us to do. Again, if an individual has to sit and design a particular tree or an aspect of a leaf, it takes a huge amount of time. But by doing this and with the immense amount of data that we have in hand, all these can be done with limited amount of time. Now, moving on to the replication of man-made structure. As you guys can see in this presentation, the image on the right is basically a geographical image of a city in the Gulf region. So obviously there are a lot of distinguishes into the that you can see environmentally, but in the background there is a lot of sand involved. The building construction materials used over there are more concrete, glass compared to the construction materials that are used in India. So what this system does is that by using advanced satellite imagery, they are able to replicate the outside modeling of these buildings, and using them as a reference, they are able to create a lot more intensive detailing to the buildings. Not just that, there's also a deep learning network that's involved that actually connects the dot between the construction materials that we have. Only in the initial step, we are only getting the background of the building, but all other materials, construction materials, the roof, the architecture type, the facadings on the rooftops, all these informations are actually gathered by using real life data on what amount of construction materials is usually preferred in those areas. And these can be done based on because there's already huge amount of construction data that's already there out in the world. So we just need to source it properly. Now, coming to the next stage is the advancements in AI generating techniques. So basically, we are focusing on two: the convolution neural network, that is the first. Now, what convolution neural network brings into the game is that its unique ability and its already established powers in detection of various recognition patterns. We are able to use CNN to improve a lot of photorealistic style into the picture. Now, this picture you can see over here, this looks a lot more real because of the artificial lighting that's processing. One of the biggest challenges that we face whenever we are trying to recreate a virtual or a real life world and making it virtual is the lighting that is involved. Now, CNN plays a huge role in improving the lighting and the natural facets that makes the overall product look much more attractive and realistic in nature. Coming to the role of generative adversarial networks, they play a huge role, not just because they subsidize all other algorithms that work in the background, but also because of the point that they mainly constitute of two different neural networks. One which suggests all the referral points that are used by all the other algorithms, especially the building data collection algorithms, but also it has another separate one that's working in the background to ensure that the data supplied by the initial neural network is not false. So by doing this, we are doing a huge help to the content creators back at the base because they don't need to go and check whether each of the data collected is actually accurate. The accuracy levels of GAN is extremely brilliant. And moreover, that GAN can also be used to fill up the gaps that are formed during data collection from cloud-based services. Now, that also plays a very pivotal role. Now, the third stage is incorporating cloud technology. Now, cloud plays a major role in the entire development of virtual worlds. It's not just what cloud enables us to do is that it helps us not to just restrict our development on a single PC. Instead of putting all the resources on a single computational device, what cloud enables us to do is to split the work among various virtual machines that are placed around the world. And by using various already existing services like the IBM Watson AI, there are a huge amount of virtual machines with extreme high graphical processing capabilities around the world. And just for our research purpose, we found out that with the existing amount of virtual machine powers around the world, we can replicate the entire world or basically collect data from the entire world within just 72 hours. And now that's not something that was being able to be done maybe 1 year or 2 years ago. So that's a huge thing that cloud technology brings into the whole virtual world development stage. Now, the next part is that even if you take the very old virtual world simulations out there in the world, a minimum amount of data that you need to install it in your personal device is almost 6,500 GBs. And now we are talking about creating a completely enhanced virtual world. So basically, it's just impossible to download all that data into a single person's device. So whenever we are talking about innovating a new technology, we have to think from a common man's point of view. So therefore, cloud technology gives us that unique ability to stream the data on a real-time basis to directly to the user's computer, and we only stream the amount of data that's completely necessary for giving him a very good experience. Now, the only backlog for us is that we should have a proper and stable, fast internet connection. Now, coming to the fourth stage, that is integration of virtual reality. Now, virtual reality is a very, very important hardware to get the complete experience of virtual worlds. Now, this is also an industry that's been rapidly growing in the last 4 or 5 years. There's n number of researchers conducted in this field, especially coming into the hardware components that go into the virtual world. Now, what a virtual reality headset actually does is it completely takes over the person's point of vision as well as his capability of hearing, because most of the modern day virtual machines comes with studio level audio systems that are already incorporated into the headset. And with modern developments in the LCD panels and OLED panels, the various studies that are taking place in the RGB modifications, the amount of realism that we'll be able to deliver using these devices is just out of the game. And moreover, the headsets are also integrated with multiple sensors that completely keeps track on what directions you are changing your head, on what intensities you are shifting your head. So basically, what this enables the software system to do is that it'll always ensure that the content that is streamed to these devices are streamed in such a way that the point of view of the user is always kept at the center of attention. So this all these things, what it basically does is it evolves the overall experience of the microverse. Now, one of the biggest challenges that virtual reality faces is the concern of the damage that it does to the eye. Now, I think this is not much of a big issue because we live in an extremely digital world. Now, saying a 10-year-old child to stop using phone is completely out of the box, because eventually he is living in a digital world. But even though there are n number of researches that are taking place in this field to reduce the damage, maybe not completely remove it, but reduce the damage. And one such biggest advantage is the introduction of blue lenses. Now, blue lenses take care of most of the harmful rays that are emitted from the LED panels or the OLED panels behind that makes a pivotal screen of the virtual headset. Moreover, that there's n number of new researches that are coming in the world of micro LEDs. Now, micro LEDs are much more safer than OLEDs because the amount of harmful rays that are emitted by micro LEDs are also very low, and it also enhances the overall experience because the amount of darkness depth that micro LEDs are able to provide is just out of the game. Now, coming to the importance of haptic feedback system. So, all these previously mentioned hardware technologies take care of the vision and the audio of the person. But feel or the sense of touch is another important thing that we have to consider, and that enables to give the user a completely immersive effect into these virtual worlds. Now, there are n number of researches again taking place in this field where eventually there is a system being developed that be able to engulf your entire body. It's a suit. So basically, all feedbacks that you might experience in a virtual world when you are using a virtual world will be transformed to your body. Now, the fifth stage is the integration of augmented reality. Now, augmented reality, unlike virtual reality, it has a lot more pros. The biggest pros is that we don't need much of a computational power or the large amount of extensive hardwares to make this a reality. Now, what AR does actually is just incorporates already existing graphical generated images into our vision of the original world. So there's very low amount of computational work that's needed. And most of the AR technologies can be just built in into various AR lenses, and they are already available in the market. Coming to the implementation and simulation. So through the simulations, we are actually trying to demonstrate two different scenarios. One is the first scenario where we told that the virtual world may be completely up to the imagination of the creator. So this is the implementation of a scenario that is completely unreal. Now, what we have done in this is that we are trying to replicate the aurora sensation that normally seen in the northern parts of the world. Now, in the first step that we took is we took a lot of referential images of mountains, of Alps around the world. We took a lot of images of the aurora structures around the world, and basically all other things that you see in the component are completely self-defined by us. Even the rocks that you can see are basically just objects that we place in some random shape. Now, the next level is the grafting. Now, when it comes to grafting, you have to implement the color, the texture, the roughness, the what all features that gathers the attention of a viewer has to be developed in the next phase. And once all that done, this is the final image that you get. Now, why this image looks so stunning is apart from all the previous steps that we followed before, the main aim or the main pivotal role of making this image look so stunning is the UV detailing that's done to the image after all the terrain grafting, all the add-ons are done. The UV detailing gives a lot of depth to the image. It helps us to do take care of factors like the reflection, like the amount of lighting, the depth of dark. Now, if you can see over here, the darkness over here is something that you only see in real life images. You cannot bring depth of darkness into the CGI world. So all these UV detailing, color saturation, they play a huge role in making an already realistic looking image much more viewable to a common man's eye. Now, for the next simulation, what we are doing is actually trying to replicate an actual city. Now, this is the second part of the virtual world that we were talking when we are trying to replicate an actually existing location on the face of the planet. Now, this is actually one part of the New York downtown city. As you can see, this is the Central Park, the Hudson River. So basically, what we do over here is that we use the already existing geographical pictures of the city using Bing Maps. They have a lot of huge amount of cloud collections on that. Now, using that images, we take around 2,000, 3,000 images, and those images are run through a terrain layout generator, which helps us getting all the layouts, all the ground rules of, or the floor plans of the buildings that are segregated around there. And once that's done, we again enable the previous step that we discussed already in the presentation. That is the terrain graphic. We try to collect data of what all building materials are normally used in the New York City. How is the weather over there? How is the extent of pollution in the city? And finally, after all that done, this is the final rendered image that we get. Now, as you can see, what makes this image so realistic is, apart from the amount of detailing that's done to each individual components like the building and all, the things that actually gather a person's attention is the reflections, is the reflections that you can see on the water, the smoggy effect that you can see on the background. Now, all these are actually scenarios that if needed we could have avoided it, but we are adding all these external or we are spending much more time on all this just to look a bit more realistic to the original user. Now all these, there are much more things that you can be added to this. Now it's much more harder to give detailing in the night time compared to the daytime, because there are a lot of artificial lights that are involved in the daytime. Actually the only thing to be taken care of is the natural source of light, that's from the sun. The only thing we need to give extra attention is for the shadowing and all other stuff. But when it comes to nighttime replications, there's a lot more work to be done using the amount of depth of darkness that is actually there in the image, the amount of external lightings that we need to give just to make the image look much more vivid to the user's eye. So this is just two simple explaining or simulations of how virtual world can be shown or portrayed to a common man. So coming to the real world implications, there are a lot of implications, but we have just kept it down to these many. So the first or the pivotal one is in the healthcare sector. Now, virtual worlds can be a breakthrough in treatment of PTSD or post-traumatic stress disorder. Why so? Because any person that has gone through a traumatic situation will never want to get back into that situation again. So the only way to treat such a person is by making him go through a similar kind of situation without putting him in the harm of it. And VR or the virtual worlds gives you the exact ability. We are having the ability to put the patient through the same scenario without having to put him in an uncontrolled situation. We can design the world completely according to the person's personalized visions, or we can include actually existing images of his home. We can recreate his entire living room. So basically, yes, I'm sorry. So coming to the medical training sector, we can incorporate VR along with haptic feedbacks to actually show a lot of the existing many of the medical procedures can be replicated using a proper VR headset and by incorporating haptic things. In military sector, we can use the AR virtual worlds to train or to make the soldiers go through combat situations without actually putting them in the risk. In the sector of aviation, instead of using extremely costly complete flight simulators that are almost 2 billion $2 million dollars in cost. You can use a simpler setting that uses a VR headset and all the instruments to give the same, maybe a better throughput. In the field of education, also it also plays a major role. Like it can enhance the existing systems. Yeah, the final one is a bit too hard to understand because this is a bit too hard for a common man to understand. Now, in the final epical of VR virtual worlds is that we'll be able to create a virtual world one day where we ourselves could go and live a part of our life in that. We will have the ability to do whatever we want without having the fear of affecting our personal characters in the real world. Now, this is a bit too extreme imagination. So, coming to the SWOT analysis and the conclusion, being a innovation that is at its budding stage, we have the capabilities to alter this technology in any way possible so that it would easily help impact a common man's life. Coming to the opportunity, the global market capital for VR-based technologies and virtual worlds is increasing at a really rapid pace. This also applies to the hardware and technical solution that goes into creating the virtual worlds. The biggest weakness of this project is that there are a lot of real world implications of virtual world, and we have only cited a very few. But the only thing that's ever going to restrict the implications is our extent of imagination. Now, coming to the threats, there is an initial difficulty in promoting this innovation. Again, that is something common that you see in all new technologies, but it will take some time to create an overall impact in the society. So, as my conclusion, I would like to say that one of the biggest problems that our nation faces for the last 2 decades is that whenever a new piece of technology is introduced into this world, we are often very late to react into it. By the time we get that information about that technology, our Western counterparts might have already exploited it. Just for reference, when cryptocurrency was introduced in 2007-8, India had no clue about it. By the time Indians not to release about it was in the late 2016-17s. By the time all the innovations and the technical upgrades that has already been done to the innovation. So normally what happens to us is we end up being we're not able to optimize on the solutions that are or the capabilities of the technical innovation that comes into the world. We often end up being exploited by the technological innovation rather than being the person to exploit it. So through this project, we are trying to give the unique opportunity to go against the flow of nature, to do something to make or leave our mark in an innovation that is at its budding stage. So the final question that we have to answer is that whether we have the capability and the open-mindedness to take such a project into the future. And if so, I hope that we won't limit the real world implications. And the only factor that's limiting is the extent of our imaginations. So thank you.